verify that g of x equals the fifth root of x plus 1 is the inverse function. Well, to find that, I'm going to find f of g of x first. So I'm going to start with f of x, and I'm going to fill in this value for f of x. So I'll take the fifth root of x plus 1 and then subtract 1. Raise that to the fifth power and then subtract 1. Well, the fifth power and the fifth root cancel each other out. I get x plus 1 minus 1, so that would just equal f. So f of g of x equals x. And now I want to find g of f of x. So I will find the fifth root of x to the fifth minus 1, that's f of x, plus 1. So I end up with the fifth root of x to the fifth, and find out that g of f of x definitely will equal x. And then find the domain and range of each function. Well, this being an odd power, for f of x, the domain is all real numbers from negative infinity to infinity. And for g of x, since this is a fifth root, an even root, what's under the radical would have to be a positive number. Because this is an odd root, we can find the odd root of a negative number. So this is also from negative infinity to infinity. Find the inverse of a function. To find the inverse, we start with y equals f of x. Rewrite the equation, replace the f of x with a y. Interchange the x and y. This is important. Interchange the x and y in the equation defining the function, and then solve the new equation for y. This equation cannot be solved uniquely for y. The function has no inverse. And then we replace the y with f inverse of x. So don't forget this final step. So we have f of x equals 4x minus 3 divided by 5. So first I'll replace that with a y. So y equals 4x minus 3 over 5. Then I'll interchange my x and y. So x equals 4y minus 3 over 5. Now I want to solve for y, so I'll multiply everything by 5 and end up with 5x equals 4y minus 3. I'll add 3 to both sides. 5x plus 3 equals 4y. So y will equal 5x plus 3 over 4, and then I'll do that final step and say f inverse of x is 5x plus 3 over 4. Now I want to graph f of x equals 5x minus 3 over 5 and its inverse on the same axes. First I'm going to do this one. I'm going to split it and say my y equals 4/5 x minus 3/5. Number my graph. I'm going to number it this way since I kind of have that fraction in there. I'm trying to get it spread out a little bit more. So negative 3/5 would be about right here. That's negative half, negative 3/5. And from there, I'm going to go up 4. So 1, 2, 3, 4, and over 5. 1, 2, 3, 4, 5. And I can, you may notice that I was doing that with just the regular dots, and that does work also. So down, I'm going to go down 4. 1, 2, 3, 4, and over 1, 2, 3, 4, 5. It'll be approximately right there. Okay. Now, I remember from the previous page that f inverse was 5x plus 3 over 4, so that would become 5/4 x plus 3/4. So my inverse will be at 3/4. My y-intercept will be at 3/4. And from there I'll go up 5. 1, 2, 3, 4, 5, and over 4. Take me to here. We're going to do it backwards. 1, 2, 3, 4, 5. 2, 3, 4, 5, and over 1, 2, 3, 4. Takes me to here. And now I can draw that line. Oops, I think this actually crosses about right there. Didn't do the best line without a ruler. Okay. So I have them too. Now you might notice they're very similar. They actually should cross down here at -3, -3. I noticed when I was graphing them. The graphs of inverse functions. So the graph of a function and its inverse are symmetric with respect to the y-axis. Y equals x. So the red here is the same we had, my f of x, where y equaled 4x minus 3 over 5, and the blue is the same we had, where the inverse was y equals 5x plus 3 over 4. And you notice this green line is the line y equals x. And if I folded along that green line, the blue and red would match up. That's what we mean by being symmetric. A business property is purchased with a promise to pay off the $60,000 loan with $16,500 in interest on the loan by making 60 monthly payments of $1,275. The amount of money remaining to be paid by the loan is given by the function f of x equals the 76,500, these two added together, minus 1,275x, where x is number of monthly payments remaining. So that's how much we still owe. We want to find the inverse of the function and use the inverse to determine how many monthly payments remain if $26,775 remains to be paid. We would start y equals 76,500 minus 1,275x, switching the x and y. So x equals 76,500 minus 1275y. Solving for y, x minus 76,500 will equal negative 12,750y. When I divide by negative 1,750, I'll have negative x over 1275, and this negative divided by negative will be a positive, so I'm going to put it in front. 60 minus x over 1275. Okay. So this is my inverse function. It's 60 minus x over 1275. Use that inverse to determine how many monthly payments remain if $26,775 remains to be paid. Well, I've reversed the x and y, so this x is now how much remains to be paid. So I have 60 minus 26,775 divided by 1275, and by dividing this, I found it as 21. So there are 39 payments left.